All right, let's get started. Hello and welcome to SIG Scheduling Deep Dive. This is the last talk of the conference, and I'm surprised that you are still here, but thank you for attending. My name is Babak Salamat. I am one of the SIG leads of SIG Scheduling. The other SIG is Klaus, who is here with us. Today, I'm going to talk about the scheduling and the scheduler and recent developments in the scheduler. But before starting, how many of you, with show of hands, think that the scheduler is boring? Nobody? Nobody? Even you guys are at Google. You should believe that scheduler is boring. In that case, it means that we haven't done our job well. So at Google, we believe that infrastructure should be boring. Basically, you should not think about it. You should not see it. And if it's really the case that you think that scheduler is not boring, then it means that we haven't done our job well. But all right, how many of you think that scheduler is good? Kubernetes scheduler is good, does whatever you want to do. All right, so you're a self-contradicting bunch, but OK. All right, so disclaimer, we are going to go fast. Because SIG deep dives are meant to be more like Q&A. So I'm going to go kind of fast over what scheduler is and what it does and recent development in the scheduler, and then give an ample time for Q&A, although there are not that many people here in the room. So at least I'll give you a little bit more time to enjoy viewing the city and seeing the things around here. So what is the scheduler? Kubernetes scheduler is this component that usually runs on the master node. It doesn't have to, but normally we run it on a master node, and is responsible for placing pods on nodes. It does not concern itself with the lifecycle management of pods. What it means is that it doesn't create pods for you. It does not care about terminating pods. Basically, it doesn't normally terminate pods, only in a particular scenario where for scheduling, it doesn't find enough resources in a cluster or nodes in a cluster. In that case, it performs preemption. That's the only case that it terminates pods. But otherwise, it does not concern itself with lifecycle of pods. Another thing is that the scheduler does not do any temporal decisions. Basically, it does not tell any nodes how many seconds or minutes it should run a pod. It just places pods on those nodes. So for that reason, the scheduler might be a little bit of a confusing name. But it's probably better than placer. So we go with the scheduler. It supports a whole slew of features. Some of them are here. For example, it supports checking. My slides are online. You don't need to take pictures. You can just download the PDF from schedule. That makes your life a little easier. It, for example, checks node resources. It does some other stuff like spreading pods among nodes, or checks affinity, anti-affinity for nodes, and also, for pods, and affinity towards nodes, like node selector and stuff like that. Supports taints and tolerations. This is just a list. You can take a look. There are lots of documentation on kubernetes.io about each one of these features. You might already be familiar with some of those. I'm not going to go into any of those in depth, but feel free to ask questions about them towards the end. So what are recent developments in this scheduler? One of the important things that we've done is improving performance of the scheduler. And this is a big effort to make the scheduler more scalable for larger clusters. So we have been able to achieve 100 pods per second now in 5,000 node clusters. 5,000 node was like a goal that we set for ourselves to reach to and get to a reasonable performance for some of these clusters with higher churn. So if your cluster is smaller, it's very likely that Kubernetes scheduler can achieve a lot more than 100 pods per second. So this is a good news for those who run large clusters. And this improvement, most of these improvements are already released. They are available in 1.14 and even older versions. Maybe they're not like all 3x, maybe 2x is available in like 1.13 and 1.12 if you're using those. And if you're using like 1.10 and older, we recommend to upgrade to a little bit newer version of Kubernetes if you need performance. Another important performance optimization that we've made is to interpod affinity and anti-affinity. We have received lot of improvement here. So interpod affinity and anti-affinity was super slow, like 1,000 times slower than many other features of the scheduler. So if you used affinity and anti-affinity, you couldn't probably, in fact, we had written this explicitly on Kubernetes.io that if you have any cluster larger than a couple hundred nodes or so, do not use affinity or anti-affinity because your pods are not going to get scheduled. So a single pod was taking like 600 milliseconds, close to a second, to get scheduled if you use this in slightly larger clusters. But now we have had like close to like 200x performance improvement. So we are within like 4 or 5x, or maybe like 3x slower than other features of Kubernetes. So this has been a huge improvement. Most of these are available, I believe, in 1.14. And there is one more improvement, which is another like 1.5x-ish in 1.15, which is the upcoming release. So if you use 1.14, you will enjoy most of these improvements. And another important thing is that we have graduated pod priority and preemption to stable in 1.14. So now you can use this feature with ease of mind. We are not going to deprecate it soon or change it in a backward incompatible way. Now, what are the planned features? So an important planned feature is even pod spreading. But why do we need this feature? We have already had anti-affinity, right? So anti-affinity was a way to say, I don't want my pods or multiple of my pods to be scheduled together on the same failure domain. A failure domain, for example, is a zone or a node, or could be any group of pod that you can arbitrarily create by placing the same label on those pods. So you could say that I do not want my pods to be placed together on the same failure domain. But what was the problem with anti-affinity? The problem was that hard pod anti-affinity, basically anti-affinity has a hard and a soft basically rule. Hard means that do not schedule if you cannot satisfy this. And soft means try to basically honor this request, but if you cannot, go ahead and schedule. The problem with soft is that if you use it with pod autoscaler does not care about these preferences. So when it wants to, you guys can correct me if I'm wrong, but when it basically wants to scale down clusters and it sees that, oh, you only have preference, it goes ahead and scales down, right? So what happens in those cases is that you have preference, so your pods will be scheduled on the same nodes, for example. If you want it to spread, it'll just remove some of those pods from the nodes and remove the node from the cluster. This is done by the autoscaler, and then scheduler goes and picks that pod, puts it on one of the existing nodes. So some people didn't want to use soft for that reason, so they wanted to go with hard pod anti-affinity. But as you can see here, if, for example, you have 4 pods, these blue circle things are pods, and if you wanted to place them on 2 zones, let's say, 2 of them could not get scheduled because you set anti-affinity in a zone towards other pods or other similar pods at least. So 2 of them would get scheduled and the other 2 wouldn't. So even pod spreading basically allows you to say that I don't care about how many pods you want to put on the same zone as long as, or in the same failure domain. I just want you to spread them evenly among whatever failure domain that I have. For example, I have 4 pods and I have 2 zones. The scheduler automatically knows that it has to put like 2 pods per zone. We also support, as a part of this, we also support specifying imbalance between these failure domains. For example, you say, I want to tolerate 2, 3, 4 imbalance of pods. So basically what it means, for example, 2 imbalance means that if a zone has 2 pods, the other one has 4 pods, it's OK. But I don't want a zone to have 2 pods if the other zone has like 5 pods. Only 2 pods of imbalance is fine. So it supports all of that. This is planned for 1.15, but there is a chance that it may not make it to 1.15. Because we are very close to the code freeze and some of the PRs are not merged yet. The other feature that we are actually working on is pod scheduling framework. So the scheduling framework is an attempt to make the scheduling architecture a pluggable one. Currently, the scheduler is a monolithic piece of code. Any changes that we make basically goes to the guts of the scheduler, to the core of the scheduler mostly. And with the addition of new, more complex features, we felt like the scheduler is becoming more and more complex, and at times it's hard to maintain. So we are introducing this new architecture where all these features will become plugins for the scheduler. It has two benefits. For us, it makes maintaining the scheduler easier. For you guys, or some of you guys, it makes it easier to customize the scheduler. So you can build plugins for the scheduler, and makes like these plugins can be merged with upstream easily. And then it also supports a sophisticated config that you can basically pick and choose all these plugins that you want to enable or disable and configure them. Another effort is gang scheduling. Gang scheduling is basically the idea that you have a series of pods or a group of pods. You want to say, either schedule all of these pods or do not schedule any of them. This is actually a feature that is oftentimes required with HPC workloads or batch processing. Many times you have like a master or masters that need a bunch of workers. If these masters are scheduled and no worker can be scheduled, those masters will just sit there wasting your resources and not making any progress. Similarly, if, for example, workers are only scheduled, they will not do any job. So basically, you can specify a group of pods that they should all be scheduled together. And if some of them cannot be scheduled, then don't schedule any of these pods. So this is also being worked on. It's available in an incubator project called KubeBatch. If you have been in our contributor summit on Monday, you might have already heard of it. There are also some of these longer-term projects that we have in mind. We know that Kubernetes Scheduler is not great for running batch workloads. There are a lot of other batch schedulers like Yarn or Slurm or similar schedulers that have been around in the industry. They do a lot better job for like lifecycle management of batch workloads or like gang scheduling, stuff like this. We know that our Kubernetes scheduler is not really great for those kind of workloads. Kubernetes from the beginning has been mostly designed for running microservices as opposed to batch jobs. But we're working on this. There are a number of these projects that we would like to add to make Kubernetes scheduler better for batch workloads. And with the help of the scheduling framework, we hope that we can deliver those soon. Another incubator project that we have is Scheduler. So the idea here is that basically when this scheduler, Kubernetes scheduler, only cares about the state of cluster at the time that it schedules a new pod. Afterwards, it doesn't care. So for example, if you set anti-FNAD or FNAD, FNAD is a better example, actually. So let's say you put FNAD on some of your pods to put two pods, for example, together on the same node. But suddenly, one of the pods, for example, terminates and disappears from that node. Kubernetes scheduler does not care at all that this affinity rule is no longer satisfied. One of the pods is gone. One of them has remained. So it doesn't care. Scheduler is an attempt to reapply some of these scheduling constraints at runtime and for the pods that are already running. It supports a number of features already. For example, it supports rebalancing node resources, distributes pods of collections when the number of nodes in the cluster change, applies interpod FNAD and anti-FNAD, applies node FNAD. Correct me if I'm missing anything, Ravi. And it's, as I said, it's available in an incubator project. That's all. OK, I did a relatively good job by finishing everything in almost 15 minutes. So if you have questions or comments, we are here to hopefully answer some of those. And if you want to find us, you can go to our homepage for Kubernetes Scheduler or SIG Scheduling or our Slack channel. You can subscribe to our mailing list or just send us messages or mention us on GitHub. Any questions? Yes, let me give you the microphone. so sure if this is on, but yeah, let's see.
Thanks. It was a question about the even pod spreading. So I can't remember what the term was, where you say, a set number out of sort of
imbalance,
delta.
for example. Yeah.
So let's say you want that to be 0, so you want exactly the same number on each node zone. What's the behavior, and if, say, a node fails and so that imbalance comes, does the scheduler then automatically reschedule, a pod to be created, or?
So basically, again, our Kubernetes scheduler does not care about runtime. It only cares at the time of the scheduling. So, right? So one of your, for example, you have 2 zones which are perfectly balanced, but suddenly one of the pods from one zone dies and goes away, right? So scheduler is not going to do anything unless the same pod, for example, or not the same exact, but if the pod is, for example, belongs to a collection, let's say a replica set, then the replica set controller is likely to create a replacement for that pod. So when that replacement comes up, then the scheduler puts it on that zone which is missing a pod.
Thanks.
Sure. Yes.
With so many conditions that the scheduler needs to take into account when scheduling a pod, can you maybe say a few words? How do you test and assert that the pod is, all things considered, is being scheduled in the right place? Like, what is the testing framework around all this?
Right. So generally, scheduler or many other components of Kubernetes have 3 main types of tests. One is unit tests, which tests like actual functions of smaller units of code, which are usually functions of the code. That's one thing that we do, but it's usually not enough for testing everything. Right? So most of the tests of scheduler are integration tests, as we call them. In integration tests, Kubernetes integration tests, we have a framework for integration tests where it brings up an API server and a scheduler and all in a single process, basically. It runs an etcd on the side. It brings up all of those. And then we have written a number of tests to, for example, check a lot of these features. Each one of these features have usually at least one, sometimes many more tests to check various scenarios. And also, we have end-to-end tests, which runs in a real cluster. These are usually the tests that we really want to make sure that end-to-end admission and scheduling and everything works and nodes actually run these workloads. So we have all these 3 tests to make sure that scheduler is reasonably reliable. Have you noticed any particular problem with?
I was curious because you need to do a proper setup before you can assert that the pod is scheduled to a particular place. So you need to actually build a lot of constraints so that the new feature that you're working on, some anti-affinity, some new version of it, is actually scheduling the pod with all these things considered. So I imagine those tests to be quite complex.
They are not too bad, actually, because we've built a library that, there are functions that we can, they're pretty modular. You can kind of like create a lot of these scenarios relatively easily in our test environments. Yeah. Yes.
On the D scheduler part, I know it's a future sort of thing, but the previous talk was about the cluster autoscaler and the concept of scaling in and sort of removing a node from the cluster. And obviously then the scheduler needing to kind of bin pack the pods. How often does that will that descheduler sort of run? Is it something that gets triggered, or is it kind of ongoing task? Do you think?
So I think it's up to you. But Ravi, do you know the answer to this question? How frequently this scheduler runs?
You can make sure that it runs as a cron job. And then set the schedule to whatever you want it to be. So it's technically just a pod, and then create a job around it with appropriate service account. That should work fine.
Thank you. Yes.
Do you have any plans to introduce some kind of dependencies between pods? Don't schedule A before B?
Yeah, so actually, I don't know if you noticed or not, as a part of supporting batch workloads, this is actually a very common thing for batch processing, right? So a lot of batch processing pipelines are really like pipelines, so they have stages. One stage should finish before the next stage can start. Yes, we are aware of that problem, and we are working on supporting dependencies. Class could probably, as far as I know, we have this plan to add like dependency management and dependency to basically batches, right? So we have that in mind. I don't know if we have any particular, basically deadline to deliver this feature. We don't, right? We cannot really make any promises at this point, but
I think we still focus on some policy enhancement to the batch workload, and we do have some pipeline for the job dependency and the task dependency for this kind, especially for the genomic workload. I'm not sure what kind of workload, because for genomic they need to do some data clarify, DNA tests or something like that. Yeah. But we don't have generally we don't have timeline for this part, but they do in our pipeline. Our first is to try to some basic concept such as job queue. We don't have finalize such kind of concept right now.
Right.
So I think this is in our pipeline. If there have some special requirement, we can have some issue or have discuss in our meeting.
One of the things is that we really try to listen to feedback from our users and prioritize based on the number of feedbacks that we receive from our users and customers. If you have a real need, please say something. Create an issue as loud as possible. Usually we listen to the louder customers more. So don't be shy. Create an issue. Go on Slack. Say, oh, my workloads are not running. I have like a cluster of 1,000 nodes, and I would bring $1 million to GKE, and we immediately schedule your work. Of course, I was joking, but yeah. Could happen in practice too sometimes.
I have a question about failure modes for event pod spreading. So let's assume that I have 3 failure domains and 100 pods.
Okay.
So they will be spread like 30 something on each, and one of the failure domains fails. So a zone is gone. So now probably my deployment or replica set or whatever control the pods will add those 30 pods.
Correct.
And what would scheduler do? Would it schedule it 50-50 on the remaining 2, or will they become pending, or is it in my control?
That's a good question. So, I don't know what you mean by in your control, but basically, scheduler will try to spread all of those among the remaining failure domains. For example, remaining nodes or remaining zones, whatever it is, and tries to rebalance all those existing ones so that if you have, for example, let's say you have 60 nodes, and you have 1 pod on each, and suddenly 30 of them disappear, for example, right? So then you have like 30 pending pods after like controllers create another 30 pods for you. So scheduler looks at these nodes, like 30 nodes are available, I have 30 pending pods, and I need to spread evenly. We'll put 1 pod per node, basically, 1 extra pod per node. Okay. Any other questions?
You mentioned at the start that scheduling should be boring, and that because no one raised their hand. Hopefully, at some point, yes. No one raised their hand. So my question would be, because the reason it's not boring for us is because the defaults kind of spread the load, and we see a lot of workloads where we have small pods requiring a small amount of resources and pods requiring the full node, and then we very quickly see that we can't schedule the large workloads with the default scheduling. Yeah. So we have to dig into the predicates and understand what we have to put there. I'm not sure if this has a solution so that people don't have to deal with this.
It is actually a problem. Basically, your problem oftentimes is referred to as fragmentation. In like academic terms. So basically, it means that you have a bunch of nodes. Each one of them has a small amount of free resources, but each one of them has, the free resources on each node is smaller than your largest pods, right? So this is something that in many cases, for example, my background is in like cluster management. I was working on Borg. Borg is like the cluster management that Google uses. So in Borg, we have something similar to dscheduler that we were talking about. In Borg terminology, it's called rescheduler. But anyway, it's the same thing. So in those cases, usually rescheduler or descheduler kicks in, finds out that, for example, there are pending pods, and I see fragmentation, and kicks in, removes some of the pods. So that's one thing that can happen by descheduler. Another possibility with the Kubernetes that we have today, and this may not apply to everybody, but if you have different priorities for these pods, and your larger pods happen to have higher priority, then preemption will take care of that for you. So it will basically remove some of those smaller pods, and chances are that those smaller pods fit on other nodes, which have like smaller amount of resources available, and it will schedule your larger pods on the free nodes. All right. Any other questions? Yes. Can you pass this?
Is scale a problem? Or like, are there any work in like improving like throughput in scheduler?
So say that again.
Is the scale a problem for the scheduler? Are we like working on like increasing the performance for the throughput?
So I don't know if you were here earlier in the talk, but we said that we've improved performance of the scheduler by like 3x. So this is relatively recent. Basically, has happened in the past 6 months. So it's available in the more recent versions of this scheduler, but. Actually, I was, just before this talk, I was talking to one of our contributors who works at Alibaba. Alibaba claims that they have been able to run clusters, Kubernetes clusters with tens of thousands of pods. Sometimes they apparently run like clusters with 30,000 pods or so. And what they have found is that the scheduler is oftentimes actually is not the bottleneck. Bottleneck is mostly on an API server and etcd. So they have had some patches to remove some of those bottlenecks, and actually that's how they achieved to reach to these like tens of thousands of pods per cluster. But scalability is a complex problem, right? So it's, if you've been to any of these scalability talks, folks from SIG Scalability and those who work on the scalability can tell you more information. But it's a complex problem. It's not just about scheduler by itself or about like the number of nodes in the cluster by itself. So it's a very multidimensional problem. If you stretch it from one side, you have to compromise on some other sides, basically. For example, if you want to run clusters of many nodes, probably you cannot also have many pods per node. So you have to basically tone down on some of those, or maybe you cannot have like many attached volumes for all of those nodes. But overall, what we have seen so far is that scheduler, at least at this point of time, that we have all these improvements, is not a major bottleneck in most of the clusters. Unless you have like particular needs that, for example, I have a 5,000 node cluster and I want to be able to schedule 1,000 pods per second, yes, then scheduler is a problem. But even if the scheduler was able to do 1,000 pods per second, I would say still you run into another problem on the API server side, because API server has to update these pods at like a rate of 1,000 pods per second, and API server wouldn't be able to do it. So yeah, there is more than just one problem to solve here. Thank you. Any other questions? Yes, you have so many questions. Sorry. Yeah, that's fine.
It's a curiosity, really. You mentioned at the start that the scheduler normally runs on the masters, and obviously that's the default approach.
Yes.
What use cases do you see where that's not the case?
So, I mean, scheduler does not have to run on the master node. In fact, some of our customers and users run custom schedulers on their regular nodes in the cluster. As long as it can communicate with the API server, it can run on any node in the cluster.
You don't see any specific use cases?
No, there's no specific use case. I mean, if you have some concerns about like availability, for example, you want to run like multiple schedulers for some reason, you can put some of these schedulers on other nodes in the cluster. So any other questions? I guess this is officially the end of the conference for you guys. I hope you enjoyed the conference and hopefully see some of you folks in the future. Thank you very much for attending.